So I will just go with Emily. So Emily is, and you can introduce yourself. So Emily is coming from Queen's University, a trainee in the lab of Dr. David Lillicrap, who is well known to many, many, many of you. So I will leave it at that. Emily?
You updated? Thank you. Okay, so good morning, everyone. My name's Emily, and today I'll be talking about my project regarding the effects of estrogen on von Willebrand factor regulation. So von Willebrand factor is an adhesive plasma glycoprotein that plays a key role in both primary hemostasis through its ability to activate and aggregate platelets at sites of vessel injury to form a platelet plug, and in secondary hemostasis through the protection of circulating coagulation factor 8, enabling it to then help drive the formation of a more stable fibrin clot. Von Willebrand factor is produced predominantly by endothelial cells, but also by megakaryocytes. And in these two cell types, it's packaged into storage granules that release VWF into the plasma upon regulated activation. And once in the plasma, VWF is cleared by different receptors on macrophages, sinusoidal endothelial cells, and hepatocytes. Now, given VWF's important role in coagulation, when it's dysregulated in some way, it can have very serious effects. For example, when VWF levels are too low, a condition known as von Willebrand disease can arise, resulting in excess bleeding. And when VWF levels are too high, people are more prone to thrombotic events, such as venous thromboembolism, which in severe cases can lead to heart attack or stroke. Now, over the past few decades, circulating VWF levels have shown variation across different female hormone states. The strongest of these associations is in pregnancy, where circulating VWF levels increase progressively throughout each trimester and drop off after birth. Interestingly, our lab was able to confirm that circulating VWF levels follow a very similar trend throughout mice pregnancy as well, which can be seen in the graph on the right. Additionally, other less established associations with contradictory evidence have suggested higher VWF levels in women during the luteal phase of their menstrual cycle when circulating sex hormones peak, and in women on oral contraceptives and hormone replacement therapies. Now, with an alteration in female hormones being at the center of all of these changes, that left us with the question, what role do hormones play in driving this effect? Honing in on pregnancy, which has the most established association with VWF, and taking a deeper look at the complex hormonal changes involved, we can see that both circulating estrogen and progesterone levels follow a very similar trend as circulating von Willebrand factor levels, which increase progressively until birth and drop off thereafter. And in 1984, Harrison and McGee wanted to look specifically at estrogen and assess the direct impacts of this hormone on VWF regulation. What they found was that estrogen dose-dependently increased the amount of VWF released into the cell culture media of human umbilical vein endothelial cells after 5 days. But despite the study being conducted in 1984, there's been little to no additional research in the field since, and the mechanisms responsible for in vivo VWF regulation by estrogen remain unknown. To address this gap in knowledge, we administered both low-dose and high-dose 21-day subcutaneous slow-releasing estrogen pellets into two different groups of mice in order to increase circulating levels of estrogen. We then collected weekly plasma samples for VWF protein analysis, and after 3 weeks, we collected lung tissue for VWF mRNA analysis. In our lung tissue analysis, we found that estrogen dose-dependently increased von Willebrand factor transcription. However, we unexpectedly found the exact opposite result in our VWF plasma analysis, with our highest dose of estrogen producing the lowest level of circulating VWF. So taking a step back and looking again at the hormone changes that occur during pregnancy, we know that both progesterone and estrogen follow the same trend as circulating von Willebrand factor levels, and that these two hormones almost always work together in many different physiological systems. So we amended our experiment to account for any potential interaction that could be contributing to this effect that we missed with the isolated use of estrogen. To do this, we first wanted to remove the primary source of these two sex hormones, the ovaries, in order to eliminate any variation caused by natural hormone fluctuation, and we conducted sham surgeries to assess the impact of the surgery itself. We then administered either estrogen-only pellets, progesterone-only pellets, or combination estrogen-progesterone pellets into our ovarioectomized mice, and we collected weekly plasma samples over 3 weeks for VWF protein analysis. And interestingly, preliminary data shows that our progesterone-only cohort was not significantly different from our control mice, and that our combination cohort had decreased circulating VWF levels, which closely parallel our estrogen-only cohort. Overall, these two experiments tell us that estrogens inversely regulate VWF transcription and plasma levels, with the resulting decrease in plasma VWF not being recovered by the addition of progesterone. These results show that while estrogens do appear to be the primary female hormone involved in VWF regulation through increased transcription, it's unclear what happens to the subsequent trafficking, release, and clearance of VWF that could be causing this discrepancy between message and protein. In the future, we aim to investigate the potential impact of estrogen on all of these phases of the VWF life cycle, as well as assess the role of other pregnancy hormones, such as prolactin. Thank you for listening.
So 2 questions. One, how do you pronounce your last name? Because when you're famous, we'll have to know that.
Emily Bucciol.
Thank you. Okay, and the second question is, have you looked at Adam TS13, and is it inversely related?
Yeah, so we haven't looked at Adam TS13, but there are studies that have shown that estrogen, these are in vitro studies with cells, and they've shown that estrogen increases the transcription and production of Adam TS13 as well. However, that would contribute to the smaller size of VWF because Adam TS13 cleaves VWF into smaller multimers. But I don't know if it would necessarily explain the reduced level of VWF that we see. So something else that we're looking into is how estrogen affects the different clearance receptors of VWF. So I don't know if I mentioned any in the talk, but there's things like CLEC4M, Siglec5, Stabilin2, and we're going to look into how estrogen affects the regulation of those as well to see if maybe they're being upregulated, which is clearing VWF from the plasma.
Really nice talk. Did you happen to look at platelet counts in relation to the VWF levels?
We haven't looked at platelet counts. It is possible that estrogen's impacting platelets as well. As far as I know, estrogen does have an effect in the activity of platelets. And additionally, the second cell type here that produces VWF, there's endothelial cells and megakaryocytes, and it appears that estrogens do seem to regulate megakaryocytes as well, so that could be having some impact because estrogen has different roles in many different systems, including bone, and it increases osteoblast activity and decreases osteoclast activity. So it's possible that somehow it could be regulating VWF through and stabilization of megakaryocytes, but yeah, we're not too sure. We haven't looked at platelet count specifically, though.
You also could be clearing plasma levels by binding to platelets too, right? So that's another clearance mechanism. So if you saw thrombocytopenia, that might suggest that you're actually increasing enough VWF that you're actually clearing it and you're falsely getting a low plasma level.
Yeah, thank you. That's a good suggestion.
Just a question on why it might go up in pregnancy is, so during pregnancy there's lots of neoangiogenesis, and unless I'm mistaken, there's VWF's the driver of neoangiogenesis. So how much of this increase is to drive some of that placentation, the whole neoangiogenesis, do you know?
Yeah, so in pregnancy there are several different changes that affect VWF levels. Part of it's even just in mechanical changes, so there's endothelial damage that can occur just from the weight of the belly pressing on the blood vessels. There's also increase in blood volume, so in pregnancy blood volume can increase up to 50%, I believe, which is quite significant, which can result in venous stasis, and even that can upregulate VWF. But about the mechanical changes account for about 50% of that increase, and the remaining 50% is just hypercoagulability, so an increase in procoagulant factors and a decrease in anticoagulants. And it's believed that hormones do play a big role in that. But definitely there are several different changes that are occurring that could be impacting VWF levels.
May I know, could you look at other factors than VWF in response to estrogen? This hormone effect is so broad. Have you looked at transcriptome-wise, for example?
Of other proteins other than VWF?
Right.
So we haven't. My project is specifically more focused on VWF, but lots of people have. people have been looking into this for a long time, and yeah, there's contradictory evidence. It depends what you read. People have said, like if you look it up on Google, it'll say, oh yeah, estrogen increases factor VIII, fibrinogen, but then I've also seen other studies who have looked in mice and they've added estrogen orally to these mice, and they don't really show much of a change in transcription, but they actually show, the study that I'm referring to showed a decrease in the activity of factor VIII. So it does kind of depend on where you look, but in terms of pregnancy increases several different coagulation factors, including factor VIII, fibrinogen, VWF, and it definitely decreases the anticoagulants as well. But estrogen's role in all of these, the regulation of all of these proteins is controversial and definitely needs a little bit more attention, I think.
Thank you.